Welcome everyone. In this video, we are going to learn about central tendency. Central tendency is the property of a data set or a set of information by virtue of which it remains clustered around some central value. The various measures of central tendency can be broadly classified in three parts: mean, median, and mode. Again, mean can be of three types: arithmetic mean, geometric mean, and harmonic mean. We'll discuss each of these concepts one by one with the help of the following dataset. Consider this dataset. Here we have observation of the price of share for a certain company in different time period. Say the observations are 36, 40, 44 and 49, and we have observations of price of shares with the number of shares sold in that prices. That is, we have a simple dataset as well as a frequency dataset. So, arithmetic mean. Arithmetic mean is defined as sum of observations divided by total number of observations. So, simple arithmetic mean is sum over I running from 1 to n xi divided by n. Here n is 4, that is we have only 4 observations. The simple arithmetic mean becomes 36 plus 40 plus 44 plus 49 divided by 4, that is 42. The formula for weighted arithmetic mean is sum over I running from 1 to n xi fi divided by summation fi. That is, see 36 into 14 plus 40 into 11 plus 44 into 9 plus 49 into 6 divided by sum of all these frequencies. That is 1628 divided by 40. Thus we get weighted arithmetic mean as 40.70. Geometric mean. Geometric mean is defined as product of all observation raised to the power of the reciprocal of total number of observation. That is, pi I running from 1 to n xi whole to the power 1 by n. We know pi is the product operator. Here number of observation is 4, so it becomes pi I running from 1 to 4 xi whole to the power 1 by 4. Thus we get expression like this: 36 multiplied by 40 multiplied by 44 multiplied by 49 whole to the power 1 by 4, with reference to our data set. Thus we get expression for simple geometric mean as this: pi I running from 1 to 4 xi whole to the power 1 by 4, that is 36 multiplied by 40 multiplied by 44 multiplied by 49 whole to the power 1 by 4. Now the formula for weighted geometric mean is pi I running from 1 to n xi to the power fi whole to the power 1 by summation fi. Now observe one interesting thing: this expression, it is in exponential form. So in order to make our calculation easier, we take logarithm both sides. After taking logarithm, this expression 1 by summation fi, it comes here, and this expression becomes summation I running from 1 to n fi log xi. Thus our calculation becomes 14 multiplied by log 36 plus 11 multiplied by log 40 plus 9 multiplied by log 44 plus 6 cross log 49 whole divided by sum of total frequencies. In order to calculate the geometric mean, take simple antilog of this expression. Harmonic mean. Harmonic mean is the reciprocal of the arithmetic mean of reciprocals. What does it mean? See, the expression for arithmetic mean is sum over I running from 1 to n xi divided by n. So arithmetic mean of reciprocals becomes summation I running from 1 to n 1 by xi divided by n. So reciprocal of the arithmetic mean of reciprocals would be this reciprocal of this expression, which is the expression of harmonic mean. See, thus we get the harmonic mean as n divided by summation I running from 1 to n 1 by xi, that is 4 divided by 1 by 36 plus 1 by 40 plus 1 by 44 plus 1 by 49, that is 4.1706. The formula for weighted harmonic mean is summation fi divided by sum over fi by xi, that is 40 divided by 14 by 36, 11 by 40, 9 by 44, 6 by 49. All these are with reference to our previous data set, that is this one. Thus we get weighted harmonic mean as 40.36815. An important relationship that you must remember, that is arithmetic mean is greater or equal to geometric mean is greater or equal to harmonic mean. The equality sign will hold only when all the observations are equal. Median. Median is the middlemost value of an ordered arrangement of observation. Suppose we have observation like this: 36, 44, 49, 40, 42. If we arrange it in either increasing or decreasing order of magnitude, we will get 36, 40, 42, 44 or 49. Here it is arranged in increasing order of magnitude. So here the middlemost value is 42 and hence it is the median. Now when we have odd number of observations, calculating the median is quite easy, but if we have even number of observation, we cannot be certain about the median. Take the example of this 36, 40, 44, 49. In that case, median can be either 40 or 44 or any value lying between these two. This is the case if we have a simple data set. If we have a group frequency data, then the formula for calculating median is m equal to L1 plus n by 2 minus capital F divided by F med multiplied by C, where L1 is the lower boundary of the median class, F is the cumulative frequency of the class preceding median class, C is the class width, F med frequency of the median class, and n total number of observation. We'll show the necessary procedure for calculation of the median in case of a group frequency data with reference to a data set. Say we have observations like this with corresponding frequencies. So in that case, you first need to construct a table like this. Here we have mid values here. We need to construct the class boundaries, then put frequencies. Now observe one thing. Here mid value is written as 60, but the class boundaries becomes 57.5 minus 262.5. How does it comes? Observe the difference between each of these observations is 5. 65 minus 65, 70 minus 65, 5, 75 minus 75. If you take the average of this, you will get 2.5. Thus we calculate the class boundary simply by adding 2.5 to the right of this and by subtracting 2.5 to the left of this. Thus the class boundary becomes 57.5 to 62.5, here 62.5 to 67.5, and accordingly. Now we put frequencies as given. Here this is an interesting method. You can take a transformation of variables by simply introducing a new variable, say y. Here y is defined as x minus 75 by 5. Thus our observations becomes minus 3, minus 2, minus 1, 0, 1, 2, 3, 4 instead of 60, 65, 70, 75, 80, 85 and all this. Actually we take this transformation just to make our computation easier. Now calculate this product f into y, and now you have to calculate cumulative frequencies. Now see, cumulative frequencies are obtained in this way. The cumulative frequency for the first observation is 4, for the second observation is 9. We get 9 in this way, 5 plus 4. Similarly for third observation it will be 31 plus 5 plus 4, that is 40. And we calculate our cumulative frequencies accordingly. Now you need to identify the median class. See, take the sum of all these observations and calculate the average. It would be something around 77.5 or 77.5 1 or 2, anything. So 77.5, this class becomes the median class, whose lower boundary is 77.5 and corresponding frequency is 114. Using this, we can calculate the median using this formula. Median equal to L1 plus n by 2 minus f by f met multiplied by c. So it is 77.5, lower boundary of the median class, n by 2, n is the total number of observation, which is 250, minus cumulative frequency of the class preceding median class, that is 79, divided by frequency of the median class, that is 114, multiplied by class width. Thus we get median as 79.52. We have taken the transformation as y equal to x minus 75 by 5. So from this we get y bar equal to x bar minus 75 by 5. Thus x bar is 75 plus 5 y bar. Thus from this table you can also calculate the mean for x. You can calculate the mean for y first from this set, that is summation fy divided by summation f as stated earlier. Then convert it using this expression. You will get the mean for mid values that is for x mode. It is a value that occurs with highest frequency. If you have a set of observation like this, where we have values in one hand with the corresponding frequencies, see here the value 20, it has the highest frequency. See here the value 20, it has the highest frequency 7, hence it is the mode. This is the case if we have a set of simple frequency distribution. If you have a grouped frequency data like this, where range of wages is given with the number of workers getting that wage, that is a frequency. The formula for calculating mode is L1 plus f naught minus f subscript minus 1 divided by 2 f naught minus f minus 1 minus f1 multiplied by c. Here L1 is a lower boundary of the modal class, f minus 1 is the frequency of the class preceding modal class, f1 is the frequency of the post modal class, f naught is the frequency of the modal class, and c is the class width. Thus observe for this data set, the class 70 to 79.99, it has the highest frequency and it is a modal class. So to calculate mode, we need to compute the class boundary of the modal class. We do this in this way by adding and subtracting 0.005 to the terminal values. Thus we get the class boundaries of the modal class as 69.995 to 79.995. Put this here, lower boundary of the modal class plus f naught minus f minus 1. F naught is the frequency of the modal class, that is 16, minus frequency of the class preceding modal class, divided by 2 into f naught minus f minus 1 minus f plus 1, that is 2 into frequency of the modal class 16 minus frequency of the class preceding modal class, that is 10, minus frequency of the post modal class, that is 14, multiplied by class width. Thus we get mode as 77.50. An important relationship that becomes very handy in case of objective type question, that is mean minus mode equal to thrice into mean minus median. Suppose mean and median is given and you are asked to calculate the mode, so you can simply calculate it by using this expression. But I would suggest to use this expression only in case of objective type questions. In case of theoretical type questions, you must show the necessary calculation. Thanks for watching this video. Stay connected.